Okay, so welcome to Math Chapter 5, Section 7. We're approaching the end of the chapter. And today we will be solving inequalities using addition or, everyone?
Subtraction.
Okay, so we're solving inequalities. So how is this different from what we were doing? Prior to this, we have been solving something else. What have we been solving? Anyone? Jimmy? Equations, right? So how is an equation different from an inequality? Everyone think. What is an inequality as compared to an equation? Lauren?
Inequalities don't equal each other.
Very good. Inequalities don't. Well, actually, they might equal each other. They have these types of signs, don't they? So let's identify these signs that you see. Okay, they sometimes have been linked with a particular animal. What animal do they like to link?
Alligators.
Alligators, right? Okay, so as we read these signs, we read them left to right. So when we look at this first sign here, the first sign, when we read it left to right, we're coming across the pointy side first, right? So what are we going to call that sign?
Less than.
Less than. Good. The greater quantity is always on the side where the open mouth is, right? So when we read these, we read them left to right, so it makes sense that this first one is a less than. If the first one is a less than, what's the second one?
Greater than.
Good, and greater than. And now this is maybe a little new to 7th grade. You have that little line beneath the less than sign. So we add something. We say that this is, say it with me, less than or?
Greater.
No, not greater than. Less than or equal to. Okay, so actually a value could be less than or it could even be equal to. Two things, one or the other, less than or equal to. So if that's true, the final sign is, let's say it.
Greater than or equal to.
Very good, greater than or equal to. Okay, so label those. Okay, so let's talk about this property of inequalities, the addition and subtraction property of inequality. So we're going to use these operations to find solutions of an inequality, just like we found a solution of an equation, right? So when might we use addition to solve an inequality? What operation might you see if we're going to use addition to solve it? Bella?
Subtraction.
Very good, subtraction. So what do I have under here? Okay, so let me cover something real quick. Okay, so in this inequality, we have x minus a is greater than b. If we want to isolate x, what is the operation we will use to do that? Tata? What will we do to both sides of that inequality? We will add what? Add a, very good. So she says add a to both sides. So let's see what that looks like. Good, we are adding a to both sides. Does that change the inequality sign? No, it's the same. Look at that, it's the same. It's still a greater than sign, okay? And so if I have, as I look at the left side of this inequality, we have negative a and a positive a, and what do we call a negative a and a positive a? What do we call those pairs? We call that opposites, right? We call that opposites, and so we say they eliminate, right? Eliminate, and it becomes 0. So we're left only with what on the left side here?
X.
X, good. So x is greater than, what's left on the right side?
B and A.
B plus A, good, both. Okay, so here is our transformed inequality. Okay, let's try this with a less than. Oh no, let's try this, I'm sorry. It would work the same with all the signs. So instead, let's try this for an inequality where we see addition. We're trying to isolate x now. Okay, so what will we do to isolate x? Bailey, what will we do? Good, she says subtract a, and we're going to do that from both sides of the inequality. Subtract a, and so let's simplify each side. And what's left on the left side, Bailey? What's left over here? Just, no, over here. When you simplify this side, right? I have plus a and minus a. So don't those eliminate the a's? No? So what's left then? Just x. Good. So x is greater than b minus a. Okay? If we knew b and a, we could simplify that too, but we don't know it. So we leave it as it is. Okay, so before we start solving more complicated inequalities, let's look at how we graph these inequalities. And so let's start with this first one. Bless you. Bless you. It says x is less than 8. Okay? So if we have that, number one, we graph a inequality that has one variable on a one-dimensional graph, which is a number line. Okay? So how are we going to show that the solutions here are values less than 8? What would we do to show that on the number line? Riley?
You have to make it a number that's less than 8.
All numbers less than 8, right? So how do you show that? Tessa? With negatives? Anthony?
Could you put like x anywhere like before 8 by like pointing an arrow?
Okay, we can point an arrow. Good, we're going to point an arrow anywhere to the left side of 8. It should be right on that number line. Okay, left side. Now, is 8 a solution of this inequality? Is 8 less than 8? No. So we don't want to include that in the solution set. But it's like the boundary, right? It's the starting area, and anything just less than it is part of the solution set. So we show that with a less than inequality by showing an open dot there on the boundary. So make sure you put an open dot on 8. Okay, it's not a solution, but it is the boundary of all the solutions. Okay? So if that's true, we would do the same sort of thing with a greater than. We're going to use open dots for less than or greater than graphs. Now let's look at B. B says y is greater than or equal to negative 1.5. So this is different, isn't it? Greater than or equal to. So could negative 1.5 be equal to negative 1.5? Yes, it is equal to. So what type of dot do you think we'll put on negative 1.5, everyone?
Closed dot.
A closed dot, not an open, it'll be closed. Good. So for the inequalities that have the equal part underneath there, we're going to use closed dots. Okay? So let's graph negative 1.5, which is right here. And we have a closed dot there, right? And now we are supposed to graph the values that are greater than negative 1.5. So which way will our arrow go? Will it go left or right?
Right.
Good, right. And notice, when you put your variable on the left side of an inequality statement, do you see how the inequality itself is pointing? The same way that the ray is pointing, this inequality is pointing to the right. This inequality is pointing to the left. And that's because the variable is on the left. So we're writing this in terms of where the variable is. Okay? Okay, so go ahead and try C and D. Graph those and then come on back and see if your graph is correct. We're going to take a couple volunteers here. So pause the video. Okay, so here are the answers. We have an open dot at K because K is greater than negative 10, but not equal to. So open dot, and the ray is pointed to the right. These numbers are greater than negative 10. 20 is greater than negative 10. So that's a true statement. In part D here, we have a solid dot on negative 4, which is correct because negative 4 is equal to negative 4. And all of the values to the left are less than negative 4. So this is a true statement as well. Okay? Okay, so now we're going to show how we can solve a little more complicated inequality and then graph it as well. So solving and graphing. This inequality is k minus 9 is less than 20. Okay, so we need to isolate k. When we solve inequalities, we're isolating the variable. What can we do to this inequality to isolate k? Katie, what can we do?
Maybe do the inverse.
Good. So what would you choose in this inequality?
Since there's a subtraction, you should choose addition.
Addition, and what will you add?
From
What were you're subtracting what here?
9.
So what are you going to add?
Add 9.
Add 9, good. Add 9 to both sides of the inequality sign. That's like the fence, right? You have to add 9 to both sides. Does that change the inequality sign? No, it stays the same. So write that down. Make sure it stays the same. And on the left side of the equation, we have k is alone. And on the right side, we have 29. Okay, so now that we know the inequality is k is less than 29, we can graph it. And so we're going to show the part of the number line that holds 29, right? We're zooming in, like on Google Maps. We're zooming in to the area of the number line that has 29. So I'll put 29 right here. And what's just a little greater than 29? 30. Okay, so now you know my number line. Every dash represents 1 unit. I don't need to do any other numbers. I mean, if you want more detail, you could write it, but you don't have to. 2 numbers tell us the scale, okay? So now the type of dot, we're going to say it together. The type of dot that we're going to put at 29. 3, 2, 1.
Open.
Open, because this is a less than. Very good. The k may not equal 29. It's just a less than. Now the question is, are we going to draw our ray to the left or to the right? And the answer is
Left.
Good, less than. And because a variable is on the left in this equation, this inequality sign is pointing the same way as the ray. Okay? If the variable was on the right, the inequality sign would not be pointing the same way. So keep your variables on the left when you can. It helps. Okay? We could pick this inequality up and turn it around, right? We could write 29 is, how would we have to write it though? 29 is greater than k, right? Now when I look at that, is the inequality sign pointing the same way as the ray? No. But it's still the same statement. It's an equivalent inequality, isn't it? It's true, but it's harder to see the graph in this, isn't it? So if you'd like to see the graph, this is beautiful. Have your variable on the left. Okay? Do I have a volunteer who would like to come and show how to solve and graph? Solve and graph. Okay, Anthony. So you may want to, we're going to pause the video. You pause that video and come back and see what Anthony did here. And here we have a beautiful inequality that has been transformed by addition. Adding 4 to both sides, isolated m. M is greater than or equal to -1. And so Anthony has a solid dot, and to the right, these are greater values than -1, in a beautiful Christmas motif, I might add. Isn't that pretty? Okay, but Jimena's asking, if this one is a -1 and it's pointed to the right, then this one was a positive and it was pointed to the left. Now, does the arrow have anything to do with positive or negative numbers?
No.
What does the arrow have to do with? It has to do with what part of the inequality? Jimena, do you know? It's this sign. It has nothing to do with the negatives, okay? So this sign is a greater than or equal to, so it goes that way.
Wait, so
No, it doesn't. As long as your m is isolated, your variable is isolated, it doesn't matter. Here is your assignment. I've got to make sure the video has it before I run out of time. There you go.
does the